This is lesson 324, more conditions of triangle similarity. So we're just going to look at these questions below. Triangle A has side lengths of 4 and 5. Triangle B has two sides that share a common ratio with triangle A. So that's saying like that we would have side-side similarity, that common ratio. So are the triangles similar? Well, here's the thing. If we had 4 and 5, let's say the common ratio was like a zoom factor of 2, so 8 and 10. Are these triangles the same? If the angle here is a different angle, let's say this angle is much larger, these are not similar triangles, right? We need all three sides to be similar. So side-side similarity is not valid. We would need to know that that third side is also proportional. If we have triangle A and triangle B that both have a 40 and 50 degree angle, so 40 and 50, obviously not drawn to scale, 40 and 50, is that enough information to know that the triangles are similar? Yeah, it is. We have angle-angle similarity, right? If we were given the side in between them, is that a valid similarity condition? Well, technically it is, because it has two sets of angles that are equal. So technically, yes. But that side in there is just extra information that we don't really need. Extra info not needed. So what other similarity conditions might there be? I mean, you could have all this extra information. We know the basics, like side, 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 angle, angle, or side, angle, side. But maybe, like we said before, you have ASA, or maybe you have SSA, or maybe you have SSAA, or other things like that, right? There's all sorts of combinations of different information that you might have in your triangles. So in class, you would kind of play around with these e-tools to determine if side, side, side is a valid similarity condition. We already know that it is, right? So if two triangles with the same three side lengths, are they always congruent? Well, let's see. If all three sides are the same, that kind of also means that the angles inside have to be the same too, because if the angle is different, let's say if these two angles are different right here, that's going to make the side opposite of that angle different amounts, right? So if all the sides are the same, that actually means all the angles are the same too, and that means the triangles are exactly the same. So I'm going to erase that and just put, yeah. Okay. Two triangles with the same three side lengths are always congruent, because that implies the angles are the same as well. If two triangles have three pairs of corresponding proportional sides, so side, 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 can you be sure the triangles are similar? Yeah, we just talked about this. They're congruent. I'm sorry, that's a little different. We have corresponding proportional sides, but that kind of is saying the same thing as when they're congruent. All of these angles, the corresponding angles have to be the same. So yes, the triangles are similar with side, side, side. We're going to be testing out SSA. Okay, so here's where we have SSA. If the angle was over here, then it would be SAS, but because it's not in between the two sides, it's SSA. And we would use this e-tool to check if it works. And it turns out that it does not work, okay? This is not enough information to say that these triangles are similar. So, no, SSA is not a valid condition. So in our check our understanding, we've kind of come to the conclusion that we've already talked about before, that the only valid conditions for similarity are side angle side similarity, angle angle similarity, and side 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 similarity. Okay? If you have extra info, like if you were given another side, that's great, that's fine. But we need to have at least this. At least this. Okay? So yeah, this lesson was kind of just playing around. I think it would have been more engaging in class. Just playing around with maybe some other conditions, seeing if they work. But the conclusion is that these three conditions are the only valid similarity conditions. So we're going to determine if the triangles below are similar, and then we're going to use a flow chart. So here we have a couple of options. We do have angle-angle similarity here, right? The 40s together, the 60s together. We also have another pair of congruent angles here in the middle. These are vertical angles, right? So those are also the same. So you could either do angle-angle similarity, or you also have sides with equal angles in between. So you could do side angle side as well. It's up to you. I'm going to do angle-angle just because I think that'll be faster. So the measure of angle A is equal to the measure of angle E that was given to us. And then the measure of angle B is equal to the measure of angle D that was given to us. And then I can write my similarity statement here. I'm going to say triangle ABC is similar to triangle EDC. Make sure I'm putting those in the right order, and that's because of angle-angle similarity. Here I have a pair of angles that's the same. I'm not sure if I have another pair of angles that are the same, but I could check. I'm going to find out what this missing angle is. I know they should all add up to 180, so I'm going to do 90 plus 28 plus angle C. Those should all add up to 180. So 90 plus 28 is 118, and I'm going to subtract that from 180. So angle C is 62, and that matches angle R. So we do have two pairs of equal angles. So I'm going to do angle-angle similarity. The measure of angle A is equal to the measure of angle, I'm sorry, not A, this is B, is equal to the measure of angle Q. And then the measure of angle C is equal to the measure of angle R. And both of those were given to us. So triangle ABC is similar to triangle PQR, and that is because of angle-angle similarity again. All right, here we have another angle-angle problem. These angles are the same, they're both right angles, and then we have a pair of vertical angles. Vertical angles here, so I'm going to say the measure of angle B is equal to the measure of angle D, and then the measure of angle C is equal to the measure of angle C. That is because of vertical angles, and then the B and D were given to us. So we can say triangle CDE is similar to triangle CBA due to angle-angle similarity. Moving on to medium, another angle-angle similarity. We've got P and T that are the same. We have a right angle here, and because these two angles make a straight line, that means that is also a right angle. So I'm going to say angle P, the measure of angle P is equal to the measure of angle T. And then the measure of angle S is equal to the measure of angle S on the other triangle. Given, given. So that means triangle TQS is similar to triangle. Now this one's kind of been slanted on its side, right? So we have to make sure we pair this up correctly. Triangle PRS. And that's because of angle-angle similarity. Lots of angles here. We have another angle. We've got the right angles. And then this triangle has angle Q. And then the small triangle also has angle Q. So we could say that angle Q, the measure of it is equal to the measure of angle Q. They both have angle Q. And then the measure of angle E is equal to the measure of angle H. Given, given. Triangle, let's say QFE is similar to triangle Q, that's SH. Now here, this is kind of a tricky one. We've got some parallel lines. And then anything that crosses parallel lines, we call it transversal. Okay, and back to our angles unit, we have two corresponding angles here that are the same. Okay. So that's one pair of angles. And then we could also treat this line as a transversal as well. That wouldn't be helpful. We actually don't have another pair of angles that we could say are similar here. So this is actually not enough information. They might be similar, but we just don't have enough information for that. So no proof for that one. All right, finally on to the spicy. Finally, I think we'll have some other than angle here. Both of these triangles share angle C, and then we have some sides. So we could do side, 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 or side, angle, side. I'm going to do side, angle, side. So we have 8 and 24. So 24 over 8 is 3. And then on the other side, we have 5 and 15. 15 over 5 is also 3. So those sides are proportional. The ratios of their sides are the same. And then I'm going to say the measure of angle C is equal to the measure of angle C. So we're doing side, angle, side similarity. So triangle BCA is similar to triangle ECD. Here we have two parallel lines. We can treat this like a transversal. So these two angles are the same because they're alternate interior angles. And then same goes for these two angles here, also alternate interior angles. So I have angle similarity here. So measure of angle, now I'm going to have to use 3 letters here to know exactly what angles I'm talking about. So the measure of angle ACB, so that's this guy, is equal to the measure of angle CBD. And now for the green ones, the measure of angle ABC, that's this one, is equal to the measure of BCD. That's this one. So then triangle CAB is similar to triangle, let's see, that would be BDC. And then finally, this one, we know this would have to be a right angle, so we've got a pair of equal angles. Here, though, we're not sure that this splits the 90-degree angle evenly, so we can't say that these two angles are the same. And we don't have any other information, so this one is also not enough information to say that they're similar.